Okay, so in this video we're going to practice long division of polynomials. It's a lot like long division of regular numbers. Okay, so I have this polynomial that I'm dividing by 2x plus 1. So the way that I like to look at it is I focus on the first term, the 2x and the 6x squared. And I guess you could look at it this way. You could say, well, what's 6x squared divided by 2x? If I take 6x squared and put it over 2x, I'm left with a 3 and an x. So I'm going to put 3x up above my division bar, right above the other x term. So I'm lining my similar terms up together. Now, just like long division, I have to distribute that value to what I'm dividing by. So 2x times 3x gives me 6x squared, and 1 times 3x gives me 3x. Just like long division, I'm going to subtract. My 6x squareds cancel, so that term has lost. 7x minus 3x is 4x. I'm going to bring down this next term of positive 2. And now the same idea. How many times does 2x go into 4x? If I divide 4x by 2x, I get 2. I'm going to distribute that 2 again to my divisor. 4x plus 2, subtract, and I get a remainder of 0. So when dividing, I've learned that 6x squared plus 7x plus 2 is equal to 2x plus 1 times 3x plus 2. Okay, so let's try that again. Now this time I'm dividing 4x squared plus 23x minus 16 by x plus 5. So I'm putting what I'm dividing into underneath the division bar, and the x plus 5 is going outside. It's the same process. 4x squared divided by x is 4x, which gives me 4x squared, and then distributing 20x, subtracting. 3x minus 16. 3x divided by x is 3. 3x plus 15, subtracting. Ooh, so this time I get a value. I have nothing left to bring down. This is my remainder. Okay, so basically when I divide 4x squared plus 23x minus 16 by x plus 5, I do not get a clean polynomial. I get something with a remainder, which means that x plus 5 must not be a factor. We'll try one more example, a little bit of a longer one, and a little bit tricky, because when I look at these two expressions, I notice that I've skipped over a term, and it's going to be really important to me that I include that term in the problem, even if I just include a 0 coefficient in front of it. So I'm going to rewrite both of my expressions with that 0 coefficient there, and then I'm going to go ahead and get started. 3x to the 4th divided by x squared gives me 3x squared. 3x to the 4th plus 0x cubed plus 3x squared, subtract, negative 4x cubed plus 9x squared. I bring down my 0x, same process, minus 4x, and you see how that minus 4x goes over that 0x. If I had not written that 0x, then I wouldn't quite know where to put it, and I might end up putting it in an incorrect place. Again, subtracting. 13x squared plus 4x plus 5. 13x squared plus 0x plus 13. Another of those examples where I have a remainder. So again, x squared plus 1 is not a factor, of 3x to the fourth minus 4x cubed plus 12x squared plus 5.